Have you ever wondered how complex industrial processes are managed? Enter the Distributed Control System, or DCS. This automated powerhouse is tasked with managing and controlling intricate processes across various sectors. But here's the twist. Unlike a centralized control system where a single controller oversees everything, a DCS operates on a network of multiple control elements, each distributed throughout the system. So a DCS is an intricate network of control elements, working together to ensure smooth operation of complex industrial processes. But how does a DCS work? At the heart of a distributed control system is the central control unit. It collects data from field devices like sensors and actuators and processes it. These field devices are spread across the plant, monitoring variables such as temperature and pressure. This data is transferred seamlessly via a robust communication network, wired or wireless. Control algorithms within the distributed control unit then analyze the data, make decisions, and send control signals back to the field devices. In essence, the DCS is a system of continuous data flow, analysis, and control, ensuring efficient operation of various equipment and processes. Now, where do we see DCS in action? Distributed control systems play a vital role in many sectors. In manufacturing, DCS helps optimize production processes, manage quality control, and oversee inventory. In chemical and nuclear processing, it's used to manage chemical reactions, batch processing, and safety monitoring. Power generation industry relies on DCS for operating power plants, turbines, and managing electricity distribution. Furthermore, in the oil and gas sector, DCS is essential for monitoring refining processes, managing pipelines, and implementing safety protocols. From controlling chemical and nuclear reactions to managing power plants, DCS has a wide range of applications across various industries. So what should we look for in a DCS? When selecting a distributed control system, key factors to consider include scalability, allowing for growth and expansion, reliability, ensuring consistent performance, redundancy, providing backup for system failures, cybersecurity, protecting against digital threats, ease of integration, facilitating smooth incorporation into existing systems, including obsolescence and maintenance, ensuring the system's longevity. These features contribute to the DCS's robust performance in demanding industrial environments. Some of the leading manufacturers and brands: Siemens, Simatic PCS 7, ABB 800XA, Emerson, Delta Vive, Honeywell, Experian PKS, Schneider, Foxborough DCS. In conclusion, a DCS is a vital tool in enhancing efficiency, productivity, and safety across various industrial sectors.